Good morning, students. Welcome to chemistry class. This is M. Veeraraju, lecturer in chemistry. And here in this session, I would like to explain energy of nth orbit. Niels Bohr has given an expression for calculating the energy of the nth orbit, that is En is equals to minus 2 pi square mz square e to the power 4 divided by n square h square. This is the energy expression. If the same expression is taken in two different cases, E1 and E2, we will get E1 by E2 is equals to Z1 square by N1 square into N2 square by Z2 square. Others are constants and can be cancelled. Before that, if we substitute the values, substituting the values of pi, comma, m, comma, e and h, we get En is equals to minus 13.6 into z square by n square electron volt by atom. This is one of the important expression now we will take this equation in two cases, once as E1, then Z1, N1, next as E2, then Z2, N2. Let us write an expression. E1 by E2 is equals to Z1 square by N1 square into N2 square by Z2 square. So it is useful even when IP value is asked, and at the same time energy of an atom in so and so orbit, then you know its atomic number. Then they ask, what is the energy of another atom, X atom, in particular orbit? You can find. Students, it is very important to remember the energies of first 4 or 5 orbits of a hydrogen atom. So I want to tell you a question like, find the energies of first 4 orbits of a hydrogen atom. Find the energies of first 4 orbits of a hydrogen atom. So let us write this formula first. Hydrogen atom in electron volt. So write the formula. En is equals to minus 13.6 into z square by n square electron volt by atom. Write down once only. For hydrogen atom, Z is equals to 1. No need to write every time. So, here you write, for a hydrogen atom, Z is equals to 1. Yes. Now you find the energy of the first orbit of hydrogen atom, that is minus 13.6 by 1 square, that is minus 13.6 electron volt by atom. We wrote in the beginning itself, or in the question itself, it is giving for atom only. So then E2 is equals to minus 13.6 second orbit, energy of first orbit, energy of second orbit by 2 square. This is 4. 4 threes, 4 fours. So minus 3.4 electron volt. Then E3 minus 13.6 by 3 square, that is minus 1.51 you will get, minus 1.51 electron volt. Then E4 minus 13.6 by 4 square, 16 won't go in 13, put 0 and point. 16 8s 128 is 136 minus 128 8. There is a point, so it becomes 80. 16 5s are 80. Even the simplification also I am explaining. Really, a student is very much interested to learn the energies of orbits. What is the energy of the first orbit of hydrogen atom? Minus 13.6 electron volt. In hydrogen atom, the electron is present in which orbit? Generally, it is in first orbit. That is what is called the ground state. And when an energy of 10.2 electron volt is supplied to it, it goes to second orbit. Then what is its energy? That is minus 13.6 plus 10.2. That is minus 3.4. Like this. If an energy of 12.75 electron volt is supplied to hydrogen atom, the electron moves from first orbit to which orbit? Then my simplest idea is, if you give 10.2 energy, it will go from 1 to 2. And here to here, a round figure we can write 1.9. And here to here, 0.65. So the total energy you have given how much? 5, 7, 1. So total energy you have supplied is positive 12.75. Then the electron goes to fourth orbit of hydrogen atom. So these values are useful in such a way. Dear students, it is very important to note down this, and then I want to give you few more expressions about the energy. Here I have given the expression electron volt per atom. Then it is also required joule per atom, then kilojoule per mole, kilocalorie per mole. How to get those expressions? I will give very simple techniques. Everyone can learn. So students, please note down. I'll move aside, and at the same time you may have to take the screenshot also. Fatafat, make it fast. Yes, my dear students. So, we can complete the joule per atom and at the same time kilojoule per mole. That previous expression once I want to write, my dear students. En is equals to minus 13.6 into Z square by N square electron volt per atom. Dear students, minus 13.6 into 1.602 into 10 power minus 19 joule per atom into Z square by N square joule per atom. Students, we may have to remember that 1 electron volt is equals to 1.602 into 10 power minus 19 joule. Very, very important. So, when I multiply this, minus 21.78, and that I want to write it as, every step I want to explain. Minus 2.178 into 10 power minus 18 into Z square by N square joule per atom. The same expression I want to write again. I have habituated to write all the detailed steps. I am preparing this video for the students who can learn very easily by sitting at home also. And hence I am writing all the detailed steps. So if I multiply this with 6.023 into 10 power 23 into Z square divided by N square, then it will be joule per mole. I want to tell you here, one direct step we write. 6 into 2.18, 13.12 into 10 to the power 5. From the 10 power 5, I am taking the 10 power 3 as kilo and another 10 power 2 into 13.12 as 1312. Sure. However, I am writing one step here. That is minus 1312 into Z square by N square kilojoule per mole. Kilojoule per mole. Okay, students. Now, what about kilocalorie per mole? If we divide the same expression by 4.182, we will get the step as minus 313.6 into Z square by N square kilocalorie per mole. En is equals to minus 313.6 into Z square by N square kilocalorie per mole. So dear students, this is the way of energy expression and relating the energy in two different cases and calculating the energy whenever if they ask either in electron volt per atom or joule per atom or joule per mole or kilojoule per mole, calorie per mole or kilocalorie per mole. These are all the expressions are very, very important to learn. So first, note down. I'll move aside and at the same time take the screenshot. Yes, my dear students, hope that uh, it is most helpful for you and give me a chance to prepare another video. And if you like it, please share and subscribe. Like. Thank you very much.